Hi. Today we're going to look at the PAP paper from 2008 going through question 26. So question 26 gives us a graph of the tide height versus time for a 24-hour period. And we're asked, when in the morning is the tide height changing most rapidly? And what is the rate of change in centimetres per minute at this time? Okay, well, we know from calculus that the time when the height, well, let's look at this. So on our y-axis we have tide height. And we know from a y versus x graph that the rate of change of y, the gradient, is the derivative at that point. So the gradient of the graph will give us the rate of change of the graph. So if we have tide height here, the value, the point for which the gradient is the steepest, is the largest, will correspond to the tide height changing most rapidly. So when is the gradient the largest in the morning? Well, here it's negative, so it's not here. And we look at this curve here, well, it's going to have what looks like a point of inflection along here. So at some point along this curve, it's going to be the maximum steepness, and that will correspond to the midpoint of the curve from the symmetry of it. So we see that starts down here and it ends here. So that's between 6 and 8. So that is to the nearest hour, 7 a.m. Okay, and then we're asked, well, what is the rate of change in centimetres per minute at this time? Well, that's just the value of the gradient. So if we extend downwards, we get, if we look at where it's effectively straight, we get this point here, and then we get this coming down like this, and we have a change in x. So our gradient, our m, will be delta h over delta t, remembering it has to be in centimetres and in minutes. So in centimetres, well, we're going from, let's draw that across, here to here. So that's 250 centimetres, 2.5 metres, to 50 centimetres. So that's 250 minus 50 over, well, what does this correspond to? Well, that's a change of, let's say, approximately an hour and a half. So an hour and a half is 90 minutes. So that's divided by 90. So that's equal to 200 over 90, which corresponds to 2.2 centimetres per minute.